A radius vector of a particle varies with time t as r equals at multiplied by 1 minus alpha t, where a is a constant vector and alpha is a positive factor. Find a, the velocity vector v and acceleration vector w of the particle as a function of time. B, the time interval delta t taken by the particle to return to initial points and distance as covered during that time. Solution. Part A. The radius vector r is given as at multiplied by 1 minus alpha t. So velocity of the particle vector v will be dr upon dt, which will be equal to a multiplied by 1 minus 2 alpha t. The acceleration of the particle will be w equals dv upon dt, and v is a multiplied by 1 minus 2 alpha t. So the acceleration w will be minus 2 alpha a. Part B of the problem. In part B, it is asked to obtain the time interval delta t to return to initial point. So the particle will return to the initial point when the radius vector r becomes 0. So time to return to initial point will be vector r equals 0 and t greater than 0, because at t equals to 0 the point is the initial point and it is the starting point of the motion. So the time will come as t equals 1 by alpha. Now let's evaluate distance traveled during the whole time of motion. So we know the formula of distance equals integral modulus of velocity dt from 0 to t. So we have the velocity vector as a multiplied by 1 minus 2 alpha t. So if you take the modulus of this vector, we will get the speed of the particle at any instant of time t. So in the time duration 0 to 1 by 2 alpha, the modulus will be a multiplied by 1 minus 2 alpha t, and in the time duration 1 by 2 alpha to 1 by alpha, the modulus will be a multiplied by 2 alpha t minus 1. So the distance covered will be the integral from 0 to 1 by 2 alpha a minus 2 alpha at dt, and integral from 1 by 2 alpha to 1 by alpha 2 alpha at minus a dt. On integration, we will get at minus alpha at square with limit 0 to 1 by 2 alpha, and alpha at square minus at with limit 1 by 2 alpha to 1 by alpha. On putting the limit, we will get the value as a by 4 alpha minus 0 plus 0 minus of minus a by 4 alpha, which will add to a by 2 alpha. This will be the distance covered by the particle to return to its initial points.